Okay, so I'm Derek. Today I'm going to be talking about quantum mechanics. Now, what quantum mechanics is it is a branch of mechanics that studies the motion and interaction of subatomic particles. These particles are smaller than atoms, and scientists and researchers believe that at the quantum level, everything is based on chance and randomness. So when studied and observed, it seems as though the subatomic particles are at many different places at once. You'll never know where one electron is going to be. So there are no certainties of where things should be in the subatomic world. So to understand this, I'll talk about an experiment that was done and has been repeated countless times by scientists and amateurs alike. And it was first presented in 1801 by a man named Thomas Young, who was a renowned scientist that made contributions to discoveries about vision, light, and energy. Now, the experiment is known as the double slit experiment, and it works like this. Imagine you have a screen, as you can see, and a wall behind it. Now you put a rectangular slit in that screen, and if you shine a light behind that screen, you'll obviously only see one beam of light. And so if you were to shoot a beam of electrons at the slit, we would also have the same result, only one beam of electrons. Now say we add two slits. What results is an interference pattern where the light interferes with each other, and then you have all the multiple beams of light. Now and then if you beam electrons, the same thing happens. So from that we can deduce that electron movements is like a wave, and not like say if we shot marbles, we would only have two lines, and then as a wave, they'll have the interference pattern. Now the thing that is confusing is that the particle before was not thought to move as a wave, and it was thought to move like a marble, which moves only basically in straight lines. Okay, so when electrons are beamed through the two slits, the same interference pattern is seen. Now the thing that is... Oh, no, sorry. My bad. Now, it is impossible to predict where the electron will land on the wall when beamed through the two slits, and you can only know the likelihood of the electron being there. And there's so many possibilities of where that electron can be that no one knows where it will be. So that's the thing that bothers all scientists alike. And the extra weird part about the experiment is that when scientists placed a measuring device at the screen with the slits to see where the electrons would go through the hole and where they would interfere, the electrons began behaving differently. As the electrons flew through the two slits, they behaved like objects such as a marble being shot through the two slits, and there were only two beams of electron on the wall that was behind. The electrons somehow knew that they were being closely observed with a detector, and they knew they were being analyzed, so they, for some reason, decided to behave differently than previous tests. So now you're probably thinking, oh, what if we put the detector there, but unplugged it and walked out of the room to kind of trick the electrons if we could? And so the scientists thought, oh, what if we did that? Would the electrons react differently? Would they still do the double slit because they thought the detector was there? And guess what the result was? They behaved in the interference pattern because for some reason they knew, oh, the detector's there, but it's not on. We're just going to go back to doing the other thing. So that's one thing that scientists are super confused about, as you might expect. And if I were to do this experiment, I would be super confused too. Now this is bizarre stuff, and it gets us thinking about how amazing and mind-blowingly weird the physics of subatomic particles is, also known as quantum mechanics. So hopefully I've taught you about quantum mechanics and you understand the basics of it. And don't worry if you didn't understand anything I'm saying today. Richard Feynman once said, I think I can safely say that nobody truly understands quantum mechanics, and he was a theoretical physicist famous for his work in this field. Thank you.
What do you think is implied then by the discovery that the electrons will behave differently if they're observed?
So, I'm guessing, like, electrons have minds of their own. Because, like, I don't know how they knew, but they just knew. And then even though, like, the scientists tried to trick the electrons into thinking they were being observed, they reacted how they would usually be without being. So they even knew, like, they were being tricked. So I think that's pretty cool how it's like they're kind of like God. They know what's going on. They know everything that's around them. So it's pretty cool. And I hope there are more discoveries on this subject and how electrons behave. Okay.